Hello and welcome to today's lesson on Newton's second law. In this lesson, we'll start by defining Newton's second law. Next, we will consider the relationship between force and the direction of acceleration, exploring how varying levels of force alter an object's acceleration. Finally, we will investigate how the mass of an object influences the force needed for acceleration. Let's get started. So far, we have explored Newton's first law to understand how objects behave when no forces are acting on them. You've also become familiar with the concept of inertia, which describes an object's resistance to changes in its state of motion. With this foundational knowledge, we can now delve deeper into how forces cause changes in an object's motion through Newton's second law. This new concept will enhance our understanding of how and why objects accelerate, enriching our broader comprehension of the laws of motion and their applications in the physical world. Newton's second law of motion is fundamental in physics and central to understanding how objects move when forces act on them. The law can be stated as:
the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass.
This is mathematically represented as F equals ma, where F represents force, m represents mass, and a represents acceleration. We will cover this equation in more detail in the next lesson. For now, let's continue developing our intuitive understanding of this law. Let's think about force and acceleration using a familiar example, a shopping cart at a grocery store. Imagine pushing an empty shopping cart. If you give the cart a gentle nudge, it moves forward but does so slowly. In this case, the force you applied is small, so the cart's acceleration is minimal. It takes time to pick up speed because the force was gentle. Now, if you push the same cart with more force, it moves forward much faster. This time, your larger force causes a bigger acceleration. The cart picks up speed more quickly because of the strong push you gave it. In essence, the larger the force applied to an object, the more rapidly it accelerates. Conversely, the smaller the force, the less the object accelerates. Now let's introduce the concept of mass into our understanding of force and acceleration. In our example, consider pushing two different shopping carts, one that's empty and one that's fully loaded with heavy groceries. When you apply the same gentle push to the empty light cart, it starts moving with ease, quickly accelerating. The cart has a low mass, so a small force is enough to make it pick up speed with little effort. But what happens with the heavy cart? If you give it the same gentle push, the heavy cart barely moves. It hardly budges because it has a much larger mass. To get it moving, you'll need to apply significantly stronger force. Even with a strong push, the heavy cart accelerates much more slowly compared to the lighter cart. This happens because the heavier cart's larger mass resists the acceleration more than the light cart's smaller mass. From this, we can understand that a heavier object, one with more mass, requires more force to accelerate at the same rate as a lighter object. And for the same applied force, a lighter object will accelerate more than a heavier object. In today's lesson, we delved into Newton's second law of motion, which explains how an object's acceleration is influenced by the force applied to it and its mass. We learned that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The relationship is straightforward. Apply a higher force to get greater acceleration, or expect less acceleration if the object has a higher mass. This understanding helps us predict how objects will move under various forces, whether in everyday situations or more complex scenarios. Watch the rest of the GCSE Physics course at Sophos Education.